Okay, so I have r equals 4. I'm going to square both sides because this is just a circle with a radius of 4. Doesn't matter what the angle is, so given any angle you want, your radius is still going to be equal to 4 since there's no theta in the situation or the problem here. So I'm going to square both sides. I get r squared is equal to 16. R squared is x squared plus y squared, so I get x squared plus y squared is equal to 16. So again, we're just converting, in this case, from polar to Cartesian. So that means we want to get rid of all the r's and thetas and replace them with x's and y's. So the quick way for this one is to square both sides, replace r squared with x squared plus y squared, and you're all set. So here I have r equals 10 sine theta. I know sine theta in this case is y is equal to r sine theta. So that means the sine of theta is equal to y over r. So I'm going to replace sine theta with y over r. So I get r equals 10 y over r. I could replace r with the square root of x squared plus y squared, but you're going to see something nice in a second. If I cross multiply, I get r squared is equal to 10y, and r squared is x squared plus y squared, so that's x squared plus y squared is equal to 10y. And then this is just going to be a circle, another circle, but I'm going to move this 10y over and complete the square. So this is x squared plus y squared minus 10y plus some number equals 0. This sum number, you always take the middle term, divide it by 2 and square it, so that's 25. So if I add 25 to this side, I must add 25 to that side. So I just completed the square on the y, so I get x squared, and if I factor this, I get y minus 5 quantity squared equals 25. So it's going to have a center at 0, 5 with a radius of 5. So we could get that information out of this here. This is a much easier form to see what a circle looks like because we're used to seeing it in the Cartesian form. Alternatively, we could have had this same situation, 10 sine theta. I could multiply both sides by r, so I get r squared is equal to 10r sine theta. R squared is equal to x squared plus y squared, so that's x squared plus y squared is equal to 10y, and then notice I'm at the same spot here as I am over here, so it's just another way to look at the same problem. So we have r is equal to negative 6 secant theta, so we want to change it into a rectangular form, so I want to get rid of the thetas and the r. So I'm just going to rewrite this as r equals negative 6 over the cosine of theta. Clearly from this form here, if I divide both sides by r, cosine is equal to x over r. So I have r equals negative 6 x over r. And if I multiply top and bottom by r, to get rid of this r down here, I have r is equal to negative 6r over x. And if I cross multiplying is pretty popular in these problems, I get xr equals negative 6r and get rid of the r because that was the whole point. I want to remove the r and the theta. So divide both sides by r, I get x equals negative 6. So the vertical line x equals negative 6 and rectangular is the same as r equals negative 6 secant theta. And I believe we saw an earlier problem where it was like some number over cosine was the vertical line. So here we have another polar equation. I want to change it into rectangular. Since we have sine, if I solve for sine here, I divide both sides by r, so I get y over r is the same thing as sine. So I get r equals 1 over 2 plus y over r. And the smartest way to handle this problem is to cross multiply because this r is going to cancel out. So I'm going to multiply this by that and that by that, so I get r times 2 plus y over r is equal to 1. So I get 2r plus y is equal to 1. And r is equal to the square root of x squared plus y squared. So r is the square root of x squared plus y squared. So I get 2 the square root of x squared plus y is equal to 1. I'm going to move that y over because in a second I'm going to get rid of this radical. Equals 1 minus y. So now I'm going to square both sides to get it into its nicest form. So that's 4 x squared plus y squared is equal to 1 minus 2y plus y squared. So that's 4x squared plus 4y squared is equal to 1 minus 2y plus y squared. And I'm going to move the y and the y squared over. So I'm going to add 2y, and subtract y squared minus y squared. So that gives me 4x squared. This is plus 3y squared plus 2y is equal to 1. And that's an okay form to leave the final answer in. The only point here is you just want to, if you can, you want to get rid of the radical. Sometimes you can't, and I think there's an example in a later problem where we'll see that. And the nice thing here was the reason that I cross-multiplied here is because I wanted to get rid of this r down in the denominator. I wanted to have it so I had the least number of r's in my problem. So I could have, at one point, r is equal to 1 over 2 plus y over r. I could have multiplied top and bottom by r and got r is equal to r over 2 plus y, and then cross multiplied, 2r. But I just introduced more r's to the problem, and the whole goal of these problems is to get rid of your r and your theta. So by now I only had 2 r's in this situation. Right over here I only had 2 r's, and ended up getting rid of it and only moving it down to 1. In this case, if I multiply top and bottom by r over r, which is a good algebra trick, there's an r right there, but then I'd have so many more r's in the problem, and your goal is to reduce the number of r's. So though that's a good algebra trick, your best bet is to have it so there's the least amount of r's in the problem. So here's our last example here. So we have a sine theta, so divide both sides by r. I get r equals 2 plus y over r. And the only way really to handle this problem is to multiply both sides by r to get that r out of the denominator. So I get r squared is equal to 2r plus y, where r squared is equal to x squared plus y squared. And r is equal to the square root of x squared plus y squared. So that's 2 times the square root of x squared plus y squared plus y. This is really the best way to leave this answer, because if I square both sides, this radical is still going to stay in the problem, or if I have to move this y over, and I try to square both sides when I have a trinomial, meaning if I have x squared plus y squared minus y is equal to 2, the square root of x squared plus y squared, if I try to square this is just horrendous. I could get rid of the radical ultimately, but this is just a lot of work to try to square this trinomial right here, which is not suggested. So this is a fine answer to leave, a very unattractive problem, but this is an okay answer to leave it in this form.